So here we go. So the goal is to get something. Let me kind of minimize this so we don't have to see our names as we go through there. So the goal is, I'm saying you can take something like what I've got over here, and why don't I just do a control A? I can start back over here. So we're going to start with an image. Now, when I'm working with images, the goal is to turn this into like a putt-putt, right? This is going to be our golf green. We're going to turn this into a golf green. When I've got these grayscale images, white and black, they have two color values. Do you know what white is? Light is 255. Black is 0. Okay. So this is an important thing to wrap. I know. Look at this. Sorry. White is fully 255 all the way up. And as they get less and less and less and less, it goes down to 0. We can also do 16-bit images, 16-bit TIFF images. And I would encourage you to use 16-bit TIFFs when you guys are doing your convolution algorithm. And if you want to know exactly what I mean by that, I'm saying down here at the very bottom of this page, I included this little thing you can make an I16 image where the values would range from 0 to 65,535. That's going to give you a lot more finer detail than just 255 different possible values in your black and white image. So this is probably the type of image that you want to work in. So here we go. I've got my unfiltered image over here. I would argue I made myself a little bit of a color palette over here. I don't want to annotate this, even though that is nice. That is in the wrong place, sir. Okay, that's super not nice. So what you can do is I'm just going into here. I'm going to start by making this entire world just black. Oh, no, I'm going to do it by making it black. So I have a black image. It's all 0. Okay. You can go in and let's say I start by making a little filled area over here. And let's say I have another spot where I want this to be the whole. Let's fill this in. I can make like a filled golf green over here. And then I've established inside of here, I've edited the colors. You can make some custom colors. So for example, if I want, I don't know, like I'm going to add this to the custom colors. I'll add this guy to the custom. So I'm adding different grayscale values to custom colors. Maybe I'll add like a more of a white one over here. And this is going to give me different levels of gradients. Add you to custom colors. So now that I've got some custom colors, I can go over here. I can go over there. Maybe I'll go in and I'll add, I don't know. I hate this sort of live coding stuff, but oh my God, you really need to, you're in the, do you understand that this is in the wrong spot? Can you see what's going on here? Like Zoom wants me, Zoom has a little annotation thing for me to draw on here. And it's like actually in the wrong spot for, because it's right where I need to like pick colors. Anyway, the point is, okay, this is sort of actually horrible, but I could save this and I could like, I don't know, like let's say I want this to be right here. So I could save this as a little image of sorts. Just kind of brush that. So what I can do is I can download this. I can do a save as, boom, save as, and unfiltered.png. So my unfiltered.png file over here, unfiltered1.png, we can sort of scroll in. This is 100 pixels by 100 pixels. The idea is that if I were to take this thing and I were to filter it, it could become a smooth like golf green, right? I can take this image and I'm just going to kind of go over here and I'm going to call this guy foo1.png. All right. So foo1.png is this sort of, it's not a smooth image, but if I were to go over into, for example, Godot, and I were to take my downloaded image and drag this into like assets, okay? So I've got foo1 is now a valid image over here. What I'm going to do is I'm going to say foo1.png. I know I'm jumping around all over the place, but what I'm telling you we have in this document is in number 4, in the last step of this, I have instructions and helper scripts that it would allow you to take an image file and convert that image file. So I have the script and the shader code that I'm going to use right now. Those are available to you. This is the script. I'm going to zoom this guy down in over here. So what this script does is it's going to load that resource. It's going to load this file that I just dragged and dropped into here. If I have a collision shape, I'm going to give myself a height map shape 3D. So I'm going to make a height map. I'm going to identify the height map. I'm going to take the pixels of that image. I'm going to run this script. And when I go over into my 3D world, I have created, I don't know if you can really see that or not, but I've created a collision shape that corresponds to that image that we have created in JS Paint. Do we agree with that or disagree with that? Okay, so the goal then is to take this thing, and if you filter it, you could presumably have something that like doesn't have abrupt edges, and you could decide, okay, this is going to be the area where you start, that's the area where you end, and you kind of have a nice sort of smooth rolly thing. You bop this thing in such a way with such an intention to try to get it over onto the other side. So that would be the end goal. What this looks like in convolution. So with the convolution, so let me take my foo1.png over here, and I'm just demonstrating the pipeline workflow. So I have foo1, and I'm putting him in here with these files. And what I'm going to do is bop in. Now, I've written my convolution. So I have my foo1 image that over here. It's hard for you to see this, but I've taken foo1, and I'm going to pass it through my convolution filter with a cone of 25. And let's see what this did. So now I've gotten a smoother image out of this, right? So if you convolve, I created this in Paint, and then I smoothed it with a big brush to the extent where these colors have been blurred together now. And now I have something that's like very different, right? So what did I call this thing? I think I called it out 3. Is that it? So I have out 3. So let's go back over here. I've got out 3. I can go into Godot. I can take my out3.png. Out3 is something that I think you guys should really like make as the higher resolution image. So let's say this, out3.png. I'm going to save this. I'm going to rerun it. And if I look at this now, I have something that looks very different, but still can look like, it's really scaled up a lot. But this is something that sort of came out of my head. And now all of a sudden it's a shape. And it's a shape that's been smoothed into such a way. So the next trick is to be like when you're doing mini golf holes, what do we have? What does every mini golf hole have around the edge of the mini golf? It's got the border, right? It's got some bumper or something like that. So we need to get a bumper for this guy. So we're going to adjust the scaling, but you're also going to need to like define edges and bumps and things like that that you put on top of here. Now, because your heights are going to be all over the place. Oh, and this actually seems like a great place for me to use my annotation. You would need to drive, right? So we need to have some sort of bumper associated with this guy. That's so nice. So how are we going to do that? How do we do this? If your initial thought is to just like make some blocks or something like that, maybe that worked. But hopefully we saw with the pill that when we start creating hundreds upon hundreds of these different blocks, it's really just going to crash your system. It's going to be too much. So it'd be much better to create a single shape that we could just put inside of there. Here's the problem. If you just make a single shape that you put inside of there as the border, not all of these elevations are the same. So what we're going to need to do is not only create the shape associated with this thing, but we're going to need to warp the elevation profile of that shape in such a way that it matches what we've got inside of here so that it can sit right at the edge of your course as you've defined this the whole way through. Yes or no? Kind of, sort of? Okay, great. So how do we do that? So do we have, I'm going to do that. Do you guys have ideas as to how we might do this? How I might do that? I might make a bumper. What sort of tools we have? Yeah, say it, Jasper. What are you thinking? Or what are you, Alex, what were you going to say? Say that again. JS Paint could work. Totally JS Paint could work. But how are we going to extrude this? How are we going to get something nice and smooth and a single defined shape? I'm going to put your brains back. I'm going to take the little time turner. Yes. What's that? Lurping? We're going a little bit further back from lurping. I'm thinking Onshape. I'm thinking freshman tech. Oh, go. Yes. Oh, yes. Oh, yes. Yes. Okay, great. If you remember nothing about CAD, now is the time to learn something about CAD because I'm sorry, but you really can't be doing this stuff without some level of CAD brain. Now, I have something I'm going to promise you something right now. I have already pre-recorded this. So if you look at this pipeline stuff, you can sketch hills. I feel like I just went over that, right? We can construct kernels through Pill. I have a little kernel script over here that you can run. This will create that filter kernel that I just made. It's on you to write a convolution algorithm. So you can write a convolution algorithm over the next few days or whatever, end of class, sure. I have a video that I made this morning and I linked it on YouTube. This is Onshape review, specifically with the things that you would need to do, what I am about to say. I've pre-recorded this so that you can watch it on your own terms, right? So we can do that. You can draw a path for your bumper, and then you can post-process that in Python and adjust the shapes. And then once you have this height map we've already done over here, you're going to pat yourself on the back when you're done with this because it's actually going to be like really, really cool. If you are in engineering or have done stuff in engineering, you may not be saying to yourself, I would like to use Onshape. You may be saying to yourself, I would like to use Fusion or Fusion 360. If that is the case, I have no problem with you using Fusion 360. I am trying to give the easiest, most straightforward things for you guys that I know everybody has access to. Okay. And I think that you can do this in Onshape in under 20 minutes. But it requires you to have that sort of like shapes defined first. So I have put in that folder some of these smooth images, and I'll do it right now, right? So in supplemental files, if you even wanted to work off of this out3.png, let's go find it. I'm going to put it right here. I'm going to call this guy class example, right? So class example.png is going to take a magical field trip. Class example.png is now part of this folder for you to go and look at if you want to work off of this thing. Let's talk about Onshape. Onshape. So here we go. I'm going to sign in. And here we go. PC Cosec. This uses your tjhsst.edu emails, and I know you guys all have access to this. I'm going to create a new document. I'm creating a new document over here for those of you playing along at home. In this new document, this is actually stupidly simple. What I'm going to do is I'm right-clicking on this surface over here and I'm making a new sketch. It really helps to have a mouse for this. I've got some new sketch over here that's associated with this guy, right? So I've got a new sketch. In this new sketch, I'm going to give myself some boundaries. So I'm going to turn off the other stuff. And I'm going to use my favorite rectangle. I'm going to make a center point rectangle. Shaboom. Do you guys remember how to adjust the dimensions of something in Onshape? Maybe the dimension tool. Do you remember the keyboard shortcut for the dimension tool? D, you act like you didn't know what you were doing. So my image was 100 pixels by 100 pixels. So I'm going to make this 100 by 100. Come on, buddy. D, 100. So this is 100 by 100. This is centered over here. So I'm right-clicking to adjust the size of this thing. Great. There's a little menu over here called Insert Image. I can import, and let's go over into import. Look at that. The class example.png, I can import this thing. And what I'm going to do is I'm going to click on this guy, and I'm going to drag it in between these two anchor points. So holy crap, I have my golf course shape in Onshape. This is sitting in there waiting for me to draw on top of it. So this thing that 20 minutes ago looked like that is now a template in Onshape. And this is going to be the basis for my golf course. So let's go, and I'm going to go make another sketch over here. And I'm going to operate on the top. And I'm using this as something that's going to sit behind me. Now, I'm going to be making this out of splines. Do you guys know what splines are? Have you heard spline? Tell me about splines. Now, you've heard of it. Yes. What do we know about splines? Tell me more. Curve. Curve? More?
It's like basically
It's something that you can cut out.
yeah, actually like this.
So, I'm going to tell you a little bit of story. I never knew what splines were until my sophomore year of college. I was working at an engine manufacturing facility. I was working at the world's largest engine manufacturing facility, Tonawanda Engine Plant. And I worked with the engineering group, and we were updating electrical kind of stuff. But they still had all the old drafting materials from the 1960s. And they would talk about how they have these huge boards. It was magical to look at. So what splines are? Have you heard, if I say the word spline, what type of material do you think? What sort of physical material might you think something spline? Glass spline? That sounds good, but plastic, thinking wood. Okay, so what they would do when you wanted to design a car in 1960 or any sort of machinery, what they would do, and this is magical, is they would take a long piece of wood and they would take something like the board over here, and they would have a big pegboard, and they would clamp this piece of wood into a particular spot. And then they would go and they would bend the wood on that spot so that this thing would go, so that my wood now would like bend it up over here. And then they'd add another anchor point over here. And then they take this edge of the long piece of wood. And then as they took this part over here and bent that part downward, because the wood had to maintain a constant second derivative, because it's like an actual physical material, this thing would bend and it takes on these really like nice natural curves that look very, very organic. So splines are a mathematical representation of a continuous second derivative like function linked by anchor points in space. That's what a spline is. This is a standard thing that's implemented in, how do I delete this? Please tell me how to delete you. How do I clear? Erase everything. Ooh, yeah. So, okay, so my splines are deleted. And I'm going to get out of here. I'm going to escape out of this. No! Stop. I confirm spline. I don't want this spline. I just want to delete you, spline. Okay, so what we're going to do with the spline, so let's say I've got this golf course, right? I can say click, click, and you're going to notice that as I click here, I'm like bending the piece of wood. And so you can sort of bend the piece of wood to create your golf boundary on your terrain that you've created. So now we've gone from this idea to this sketch, the terrain, to a boundary over here. We're going to do our old friend. I'm going to finish the sketch. I'm going to extrude this sketch. Do you remember extrude? You did something in freshman tech. You did it. I swear you did it. You did extrude. No? Okay. Well, I think you did. You can make the works. I don't suggest making the workspace unit pixels. I suggest going into the document detail, or sorry, not document details. I suggest going into the document workspace units over here, and you can either make it millimeter or meter. One of the trickiest things about all of this is going to be to get all of your units aligned, because these things are not going to play nicely with each other. You're going to have to identify what size and what shape these are. So right now, this is just a shell that I've created. And then it makes it really, really straightforward. I can click thicken, and I can do a mid-plane thicken on this thing. So 5 millimeters, sure, you can adjust this. This is like comically large, right, for a golf course, but this is an actual shape. How long did that take me? I don't know, 5 minutes, right? Like I'm What's that?
Yeah, it'll take about 5 minutes.
It'll take about 5 minutes. Okay. But this is part of a pipeline. I'm going to go in and I'm going to turn off my my finger. I'm going to turn off my finger, and now I have part one over here. I'm going to take my part and I'm going to export this, and I'm going to export it as a GLTF. So you want to make sure that you're operating within GLTF here, just because GLTF is going to preserve things the way you want them to be preserved. Other different types of shapes are not going to preserve them the way you want them to be preserved. GLTF is going to be your buddy here. So I can call this, I don't know, border. And he's going to download, presumably. So that should be in downloads, maybe. Did you download? Okay, there it downloaded. So I've got my border.gltf file. And the next step is going to be to go back. Where am I? The next step is going to be the post-processing in BPY. So post-processing this in Blender is going to be where you're going to sample every single point on that 2D shape of your golf course that you just made, and you're going to adjust the elevation of every point of that file to make sure that that thing can sit nicely, so that when it's up high, your border goes up when the terrain goes up, and your border goes down when the terrain goes down. So you're going to you're going to shift the elevation, you're going to shift the Y elevation of each point. I don't have that implemented right now, so I'm not going to show that, but I think that's a fairly straightforward operation. I have a helper script to get you started with that. So that is going to take some thought, and that's going to take some time. That's not going to be as straightforward as some of this other stuff. However, when you get done with this, so let's go back over here. When you get done and you have properly shaped this thing, we can go back in to your GLTF file. And if I were to bring in my GLTF file, assuming this properly loads, I should be able to instantiate the child scene. And let's see what we are looking at over here. So this border, there he is, right? So that thing is in there. The root scale is 1. I'm probably going to want that to be something more along the lines of, like, let's start with 10. You're going to have to guess and check to see exactly. There he is. So this was importing as millimeters. So it would make sense that it's like super duper teeny tiny. So it's probably closer to either 100 or 1,000 that I'm actually going to need to. No, that looks more like 1,000. So I'm sorry, I'm guessing and checking over here. Let's go here. So we want to make sure. Let's re-import. Okay, so now that I've re-imported him as 1,000, holy mackerel, I have something. I have something, a little golf course that we've made over here. So my Node 3D, I am going to turn your rotation to exactly 90 degrees. So that's sort of off a little bit. It may not look the best. And this is my root. I'm going to put you up in there, and I'm going to look at you. It may not look the best, but with a little bit of work and with a little bit of scaling and with a little bit of offsetting, you guys are going to be able to create a space and assign materials to these things in a way that you can begin to build other things up on top of it. And I think that it would not be right to go through this without having some of this pipeline of creating shapes, creating terrains, and adding this. This is sort of a necessary design, and I'm hoping for you that this is not, like, conceptually we can get it, and if you feel so empowered to go into Fusion to do more complicated things, like make ramps, right? You could make a ramp. You could make a little bridge. These are valid options for you to do inside of it. But that's kind of the next phase of this operation. Yes or no? Does it clear where I want you to go from here? This is a big chunk. It requires you to implement convolution, and it's going to possibly require you to do some other stuff. I'm going to say go, and I am here to help you, and it's going to be maybe more of me trying to be hands-on with you. Okay? So that's a reasonable goal. Once we have this, then we can worry about the mechanics of a player hitting a ball and creating a rigid body for them that moves to a directed area within the sense. Okay, cool. Good. Rock and roll. I'm going to shut down this show. So stopping share, ending this meeting.